Hey guys! Welcome back to my channel. It's me, Andrew Guilhem Dasalia from BSc 1C, and this is Physics for Engineers. In this video, I'm going to give an example regarding motion at angular acceleration. So, without further ado, let's get started. So, here's the problem. A disk initially rotating at 3.5 radian per second makes 3 complete turns before coming to a stop. So letter A, calculate its angular acceleration, and letter B, calculate the time it takes to come to a stop. So for letter A, ang hinahanap sa atin is yung angular acceleration. But before that, meron na sa ating given na 3 revolutions kasi based on the problem, sabi nga dito is 3 complete turns. So yung 3 complete turns na yan is equal to 3 revolutions. So, theta, or yung angular position natin, is equal to 3 revolutions. Pero, sabi nga, di ba, sa lahat ng mga problem natin, ang gagamitin natin ay yung angle natin, lagi natin siyang i-convert into radians. So, theta is equal to 3 revolutions times yung factor natin. So, 1 revolution is equal to 2 pi radian. So, pwede na natin i-cancel yung revolution dyan. So, by calculating the values, ang revolution natin, or yung revolution natin, is equal to 6 pi radians. Since nakuha na natin yung angular position natin or yung angular displacement natin into radian, pwede na natin i-calculate yung acceleration natin. So, we're going to use the fifth equation. So, ito siya. Final angular velocity squared is equal to initial angular velocity squared plus 2 times yung great alpha or yung angular acceleration natin times theta. And now, ang hinahanap sa atin is ito, yung angular acceleration natin. So, magde-derive lang tayo ng formula dyan. So, angular acceleration natin is equal to final angular velocity squared minus initial angular velocity squared over 2 theta. So, magsasubstitute na tayo ng values natin. So, angular acceleration is equal to, ang final velocity natin is equal to 0. Dahil makikita natin dito, ito yung initial velocity niya, or yung angular velocity niya, and nag-stop siya. So, ibig sabihin, naka-stop na siya, meaning, yung velocity niya, or yung final velocity natin is equal to 0. Minus, yung initial angular velocity natin is equal to 3.5 radian per second quantity squared over 2 times yung angular position natin, ito siya, in radian, na 6 pi radians. So, by calculating the values, ang angular acceleration natin is equal to negative 0.3249 radian per second squared. Now, let's proceed sa letter B natin. Calculate the time it takes to come to a stop. So, basically, ang hinahanap sa atin is yung time. And ang gagamitin natin dito, para makuha natin yung time, is yung first equation na final angular velocity is equal to initial angular velocity plus angular acceleration times the time. So, ito yung hinahanap sa atin, yung time. So, magde-derive lang ulit tayo ng formula. So, time is equal to final angular velocity minus the initial angular velocity over yung angular acceleration. So, ito, 0 na nga ulit to. So, time is equal to 0 minus yung initial angular velocity ulit natin na 3.5 radian per second over yung angular acceleration natin. Ito yung nakuha natin sa letter A na negative 0.03249 radian per second squared. So, cancel. Ang matitira sa atin is yung second na lang. So, time now, or yung time bago siya makapunta sa, or bago siya huminto, is equal to 10.773 seconds. And this is the answer to our problem.